Can you guys hear me?
Yes, we can hear you.
Okay, all right, good. I think I'm gonna turn off the camera in order to save on bandwidth. Okay.
Okay.
Good. I think I'm gonna choose one of you guys to give us a recap of what we touched on last week. Susu, the mic is yours. Can you give us a quick recap of what we touched on the last week during the last session?
Yes. So just to summarize, last week we took a look at some introduction to cloud on-prem and then the differences, the various type of cloud as well. And then we went into how to create an AWS account and how to kind of add your two-factor authentication to it and how to log in. And also we looked into roles and permissions as well. We also learned a lot you need to create a separate account that you use for the AWS. You don't use the root account. Then we delve into understanding VPCs, internet gateway, subnets, and then we look at how you can go about creating them. We look at two ways. You can use the VPC and more, where you just fill in the VPC name, and then AWS will suggest the route tables, the subnets, everything for you. You even see a visual diagram of what it encompasses. And then we went through the VPC only approach as well, where it was a bit of manual how we create. So first you create the VPC, then we go about creating routing tables, internet gateways, and subnets.
Awesome. I think that's a good recap. I don't have anything else to add. In that case, let's dive into today's session. I will start sharing my screen right now. Let's see which one can we get. Entire screen. Good. Let me know what you guys are seeing on your side.
Yes, it's session 4.
Okay, session 4. Good. I think last week we ended up the VPC session, and today we're going to tackle the session 4, which is basically EC2 instances. Anybody has any idea what is an EC2 instance for?
Yes, from understanding is like your own computer in the cloud that is always on, that you can use and do stuff.
All right, that's good. I think that's a starting point. Basically, it's your server in the cloud. Just to put it, I usually prefer saying server than saying computer in the cloud. Therefore, it's your server in the cloud. It's basically a way of deploying EC2 deploying servers in the cloud from AWS perspective. And just like on-prem, your servers have a certain properties. And from AWS side, okay, let's put it this way. From on-prem perspective, what are usually the property of your server? You have computes, which is usually the CPU. You have memories, you have storage, you have network. And I think that's all most of the time. And from an EC2 instance side, is literally the same. You have the instance type, which usually represent your CPU or how do you call it, the server type that you want to use. For instance, let's say you're buying a Dell Xeon processor, for instance. That is a reference of instance type. Then you have AMI. AMI usually refer to, let's say, the template of the operating system. Similarly, when you go on-prem, usually when you're going to deploy a server, usually you have you either have a pen drive with the operating system pre-installed on it that you're going to boot from and then do your installation, or you simply going to use a DVD as old-fashioned, right? Now, from an EC2 instance perspective, instead of having to use the pen drive or how do you call it, a DVD, you're going to boot from an AMI, which is basically your operating system and all the application. Then you have key pairs. Key pairs, this simply is a secure way of connecting to your instance. Usually, it's like a password or an encrypted password, if I can put it that way. Okay. Then you have the storage, which is your disk. Then you have an IP address, and then you have a subnet. Now, Because it's a server you are renting in the cloud. Obviously, Amazon cannot predefine what you're going to use the server for. Therefore, what Amazon does is that it grouped its servers in multiple categories. You have general purpose. Basically, these are servers that you just use for your day-to-day activity, and they come with a certain amount of memory, networking, and all those things. Then you have the compute optimized. Those are servers with higher processing power. That means when we are talking about Xeon, we're talking about the gigahertz and all those things. That's what it falls into. Then you have memory optimized. Those are servers that are most of the time with very high memory, okay, and they are adequate for databases. Then you have GPU optimized for machine learning and AI, like we're seeing today. And then you have storage optimized. And the storage optimized are basically servers with higher IOPS, which means that you can have a server with a certain drive with a certain speed. Typically, for instance, when you're buying a server today, you have the possibility of choosing between SSD, M2, how do you call it, SATA drive or SAS drive and all those things. That's the category of the storage, okay? Am I making any sense?
Yes.
Okay. And if you look on the right side of the diagram, you can see pretty well how AWS kind of name its servers, where you're going to see something like C7GN 2X large, for instance. In this particular naming convention, you can see the series, the generation of the server, the options, the family of the instance, and then you have the instance size, which together form the instance type. I think we're going to look at an example soon. Okay, somebody else also joining. The next thing we're going to look at is the EC2 instance overview. Now, like in the cloud, I mean, we can put it this way. In the cloud, usually the servers are hosted in a particular way. From AWS side perspective, you have the tenancy. The tenancy determines basically if your server is going to be dedicated to you, or where the server is going to be hosted is going to be hosted uniquely on your own, on a dedicated server or a shared server. Let me bring it back to on-prem. Some of you who have experience in hypervisor, you know pretty well that with a hypervisor, what you have is that you have the underlying infrastructure, which is made up of your physical servers. And then on top of it, you have the software that you are running as a hypervisor. Type 1, most of the time is either VMware or Proxmox or any of those types. Now, the same thing applies to the cloud. Same thing applies to AWS, which means that you have a common underlying hardware with everybody else, but on top of it, you have secure virtual machines that are provisioned to you. But there are special cases whereby you may decide to have a dedicated instance, which means that what AWS is going to do is that instead of having to provision your server on a shared infrastructure, they're going to make a server available to you on which you're going to deploy your own instance. And most of the time, what's the category you're going to have is that you're going to have something like dedicated instance tenancy, where your instance is running on a hardware that is dedicated to a single AWS account, which means that you have your AWS account. AWS has made a physical server available to you on your account where you can actually deploy all your server. There's another one we call dedicated host tenancy or dedicated host. Simply in that situation, what AWS does is that they provision a server for you that they give you full control to the underlying hardware. That is one of the distinctions between dedicated instance and dedicated host. Dedicated instance simply means that you're going to have a server that is dedicated to you in your account, but you don't control the underlying hardware. But on a dedicated host, you have a server that is available to you in your account as a physical server, and you have full control over the underlying host. Then you have the default tenancy, which we call shared tenancy, where your server is sharing the same underlying hardware as anybody else. That session can be quite confusing, and I'm wondering if you guys, get a gist of what I'm talking about. Anybody has a question? Any question? No question. Now we're going to move to pricing. That's the interesting part. And like the rule of thumb with the cloud is that the type of instance you provision will determine how much you're going to pay. And beyond that also, the tenancy type also has an impact on the price. Now, when you go to AWS and you're provisioning your instance, most of the time you are subject to 3 types of pricing. You have the on-demand, which means that you pay the compute capacity by the hour or second. And as long as the instance is running, you'll be billed for it, okay? And this one, it's assuming that you don't have any real commitment towards AWS. You spin it up, you use it. When you're done with what you're working on, you shut it down. Then we have spot instances. Spot instances basically are more like instances that AWS is not using, or capacity in the cloud that AWS is not using, that AWS can decide to make available to you, that you can spin up. But then anytime AWS needs it for an on-demand request, they can take it back from you. Why is that option available? That option is usually available for people that are doing testing. For instance, if you're prototyping a project, for instance, you don't want to spend all your money on an on-demand instance, but rather you can spin up a spot instance. And when you compare the pricing with an on-demand, you're looking at 90%, price reduction compared to on-demand. Just that you can use spot instance for production, because when AWS needs that particular resource, they're going to pull it off your legs. Okay? Then you have reserved instances. Reserved instances are more like a long-term commitment. Usually it comes between 1 and 3 years. And when you spin those kind of instances, that means that you're going to get up to 75% discount. But it will vary. When I say up to, that means it can be far lower, but the maximum you can get in terms of discount on those one is 75%. Is that clear?
It's clear. I have a question on the spot instances.
Okay, go ahead.
So if they take that space, do they respawn your services at a different place, or like your configuration stuff are lost?
No. Basically, when they need that resources, they're simply just going to take the compute from you. But recently, they've done some, in the past, when they take that compute from you, usually you end up losing your data also. But recently, they've introduced new features that allow you to preserve the data that you have on your spot instances. Okay, that means when they take it, they are not going to re-provision it. Basically, your server is just going to go off. But lately, you'll be able to have your data that you were having available on that day on that server. Is that clear?
Okay, that's clear.
Okay, that means for all your projects, that's like prototyping, proof of concept. I'll really suggest that you always go with a spot instance, because it saves you a lot of trouble and a lot of money in your pocket. Okay.
Yeah. Okay.
Then we have the AWS. You have the EC2 storage type. Similar to on-prem, AWS has, I think, quite a number of storage type. But for this project, for this particular presentation, we're just going to focus on, I think, 3 of them, which is we have the EBS, which is basically your hard drive. Is basically having a hard drive in your server, and is used for heavy workload or anything else. Then you have ephemeral storage, which is called instant store. Basically, those are also high performing storage, but the downside is that when the host on which the server is running goes off, you lose that capacity. I mean, what's the difference between EBS and instant store? The major difference is that EBS is highly available, meaning that if anything happened to your server, your storage is still available. But on the instant store, because the storage is provisioned on the host in which the virtual machine is running on, when anything happened to that particular underlying host, the drive is also affected. Okay, that means if you are provisioning any instance for any workload, it's highly recommended that you always go with an EBS. Then you have other file servers, like for instance, you have EFS, and I think those who work with Linux are well aware of what is an EFS storage. It's basically a shared storage over the network that AWS has a service. And then you have FFS, which is basically for the Windows people. Is similar to, if identical to SMB SIP, which we use most of the time for file sharing in Windows environments. Any question? No question. Okay. Now we're gonna go to look at the migration type. Like we did with the networking, whereby you are required to actually do proper sizing, evaluation of your network, and proper planning. The same thing applies to migrating your server workload to AWS. Now, there are mostly three categories of server migration. You have lift and shift, which simply means that you have a workload, you have a virtual machine, physical server on-prem, and all you're doing is that you are moving that particular workload as it is to AWS. Okay, you are rehosting your server on AWS with little to no change. Okay, and there are a couple of tools that you have available. For instance, you have AWS Application Migration Service, which in the past was called Cloud Endure, that allow you to basically replicate your block storage and all the configuration of your physical server on AWS as EC2 instance. Then you have VM import export is also another service from AWS that allow you, this time instead of having to migrate or replicate the configuration and the virtual disk of your server or physical disk of your server, you are literally moving OVFR, basically virtual disk, onto AWS. And this is usually used for virtual machine migration. But in the past, there are a lot of tools that you can use to even convert physical disks into virtual disks. That means using this VM import, you can actually migrate the disk onto AWS and then spin up an EC2 instance and attach the disk to it. Then we have replatforming. Basically, with replatforming, you're doing something similar to lift and shift, just that you are taking advantage of some of the services of AWS, especially from the database front end, whereby instead of having to lift and shift your database, you are looking at the various type of database services that AWS is offering, which is usually RDS services and so forth. Okay, and for that, the migration is usually done by using AWS Data Migration Services. It's a very cool service that allows you to connect to one database and thus replicate the entire schema as well as the data from that particular database to another database running on AWS, either as an EC2 instance or a managed service. Then you have the refactoring. That's the most complicated part, whereby you basically redesign your entire application to be cloud native. And in that case, you're going to make use of tools like Elastic Container Services, EKS, and then Fargate. Okay, those are basically the migration strategy that you have when you're moving compute workloads onto AWS. Now, what is the final stage of that particular migration process? Obviously, the same thing applies. You have to have a good documentation of your application, which means that you have to do a proper assessment of the server compute requirement, the application dependency, network configuration. You also have to make sure that the operating system that you are migrating to AWS is quite compatible. And most operating systems are actually available on AWS. But there are cases whereby, yeah, you have operating systems that are not available, but they are workaround. For instance, I think in the past I've done a migration of how do you call it, True NAS, which is an open source sound storage solution or network storage solution. Of course, that operating system doesn't really exist natively on AWS, but basically what I got to do is that I have to import the disk onto AWS and then spin up a Linux EC2 instance and attach the volume to it. And that is one hack that you're going to have most of the time to do when you are dealing with operating systems that are not natively supported on AWS, but they are similar to Linux. Okay, and with Linux side, it's quite easy. On the Windows side, it gets a bit complicated because with Windows, you are dealing with Microsoft licenses that also come into play. Now, AWS has the option for you to spin up an instance and then acquire the Windows license from them, which is part of the billing that you're going to get for that particular instance. Or you can bring your own license onto AWS. Okay. Then we're also looking at the networking part, whereby you have to, because you are migrating your workload onto AWS, you must be sure if that workload needs to be exposed to the internet or it has to be in a private subnet. And if it's in a private subnet and you are somewhere in the office back in the crowd, how do you connect to that particular instance in a private subnet? I mean, you have to look at the connectivity from the side-to-side perspective and all the VPC configuration that you have to do. Okay. Yeah, this is the summary basically from this perspective. Now we're going to jump into the lab where we're going to spin up an EC2 instance. But before we proceed to the lab, any question around EC2 instances? And I hope it was not too fast. If you guys want me to go over something that you've missed, let me know, okay? All right. Now, for the lab, what we're going to do is to resume from where we stopped the last time. I think you all remember that the last time, what we did is that we provisioned two types of VPC, and we did the, how do you call it, the wizard-driven VPC provisioning with network, where everything is kind of automated from AWS perspective. And then we also did a manual one, okay? Now, today we're going to spin up EC2 instance. But before we do that, I want to also look at a third way of we provisioning EC2, how do you call it, VPC or networking most of the time, which is usually the preferred method for me or for anybody who is actually in DevOps or cloud engineering, which is to use third-party tools like Terraform. And I guess somebody has asked a question the last time if we can use Terraform for the provisioning of a VPC, and the answer is totally yes. Now, what we're going to do is that we're going to look at the small Terraform codes that I have in place that allow us to spin up a VPC, but this time I think we're going to use a different region in order to have more clarity. Okay. This is a small code where what the code does is, I think for those who are familiar with Terraform, you basically have the provider that is defined over here that allow us to spin up to interact with AWS. Then we have the VPC configuration using a module. I think this code, I think I'll make the link available for anybody who's interested in this particular module. It's a custom module that I usually host myself, that I've built to make these things quite easy for me. Now, what we are doing here is that we are provisioning a VPC with certain parameters. And from here, we can see the VPC name is going to be called training VPC 3. We're going to deploy it in this region, which is EU East 1. I guess that should be somewhere in Ireland, I guess. Yes, this is Ireland. I think this is where we're going to deploy this particular VPC in order to have it really clean. Right now, by default, there's nothing really over here. Yeah, you can see the VPC CIDR block. Yeah, go ahead, Susu.
Yeah, I'm seeing that Ireland. Ireland is EU West 1. What we have is EU East.
Yeah, I think we're going to update that. Okay. We'll update that so that it's aligned with it. And usually I prefer spin up instance in Ireland and London because I think we have lower latency from that region compared to South Africa in my own experience. Yeah. Okay. Now we say we are using EU West 1, right? Okay. Are you guys okay with the CIDR block, or I should give you something that you are more familiar with? Okay. Nobody has a concern. And we're going to spin up these subnets along with the deployment, where we are going to deploy 3 public subnets and 3 private subnets. And these three public subnets are gonna have a default route directly to the IGW, and whereas the private subnets are going to interact with NAT gateway. And I believe when you go to the module parts, let's see here, you can see that I've set enable NAT gateway to true, and the NAT gateway is going to be deployed in a public subnets 1. Okay. I guess that's it. I think the output will be a bunch of things. Okay, I think I have to fix this one. Yes, I think that's it. Let's see what we can do now. Let me move this one to the right side so that we can have more visibility. AV, let me see. I cannot remember what I've used for votes. And for my use case, I think there's a step that I've skipped in this exercise, is how to actually use a key, how do you call it, an SS key and secret key. Probably I'll touch on that. Remember the last time when we're creating a user, we create a user called, I think we go to IAM. Who can remember the user account that we created? I think it's the same user account I used to log on to this. We have the user, and the user is called AWS trainer. The last time when we created that, we didn't set up the secret key, or let's call it the access keys. Who has any idea what an access key is for?
I'll say something that enables you to communicate with AWS services.
Okay, all right. That's basically your keeper that allow you to interact with AWS services, especially from a programmatic perspective. Okay. From the console, obviously you need a username and password, but for you to use anything like CLI, SDK, and all those things, you need an access key. And for Terraform, we're using the access key also. And in my case, I usually store my access key in vaults. Maybe I have that documentation somewhere that I will share, just in case somebody needs it. Okay. Just give me a second. Let me find this thing I'm looking for. Let's see. Okay, let's see. Okay, yeah, I think what we're gonna use AV training -- Terraform init. Basically, what we are doing here, we are initializing the Terraform module. Okay. And then I need my password to the vaults. Let's see if we're gonna get any error. And obviously, the last time we set up an MFA, and the vault also require, or how do you call it, the connection to AWS over access key also require an MFA. Let me see if I can remember what I have here. It's 9.7. Okay, let's see. All right, let's see if we're gonna get any error. Okay, the directory. Okay, good. That's the one thing. What are we? Okay, we are in the wrong directory. Let me see. PWD. ls. Okay, we're going to the directory in which the code is. Now we go back here again and write init. Okay, it's initializing. And as you can see over here, it's actually pulling the module from my GitHub repository. Okay, there's no error so far. Then let's now run. Let's see if validates will give any error. If there's anything that is wrong, it's going to pop up. Okay, here we're going to talk, we're saying subnets undeclared variable in this one. Okay, let's see. Which line are we talking about? Go to the variable because we did some few adjustments. Okay, yeah, the variable name subnet 3 here. This is where the error is. We need to adjust this one too. Then we go back over here. Let's see. Okay, there's no error. For those who are familiar with Terraform, those are the few things you're gonna go run initialize to initialize the module, run validate to validate the code. Now you're gonna run Terraform plan to see the outputs of your configuration. And as you can see, basically we are going to deploy basically 18 resources or 18 changes. And you can see can be long, but basically we have the public IP address for the NATs instance. Yeah. Then we have the internet gateway. We have the NAT gateway. We have the routing table for all those various components. Okay, let's just go on and put apply. And I'm going to say yes. And we just have to wait for it to start creating. Usually it will just take some few minutes. Thanks some of the aspects. Yeah. Okay. Now it's moving to the NAT gateway deployments. Okay. I think the NAT gateway can take some time to provision, but all you got to do is to wait. I just want to make sure that we have exactly what we are looking for. Okay, we still have some time left. That gateway is still creating. Okay, while that is ongoing, we can just come over here. I think we go to VPC. As you can see, the VPC is being created. Let's see if it's done. No, it's still going with the NAT gateway. This is your VPC. And you can see it has all the tagging that we needed. Tag, because I think there's a couple of tags that are requested that issue attached to this. Then we go to the subnet side. As you can see, these are the 3 subnets that's supposed to be provisioned. And they are all provisioned as expected. And if I take the public subnet, for instance, one of them, we have the routing table, which is also a custom routing table that is based on the private subnet name. You can see over the public to the gateway routing table, and it has also added the internet IGW to it automatically. We go to the private one. The private one is still creating, and you can see that there's no routing table to the NAT gateway yet. Let's see if it's done. Okay, it's done. Let me refresh this one and see if it's just eventual consistency. Oh, yes. And you see the gateway for the private subnet goes to the NAT gateway. And that's the beauty of Terraform. And you can see at the end of the commands of the execution of the Terraform apply, we have the output, all these output that are given to us. We have the VPC ID, the various subnet, and their various subnet ID. And then we have the NAT gateway. Exactly what you're going to see on the console is what you see also over here. Okay, that means this is another way of creating resources. And the cool thing with this one is that if I want to destroy it, I think at the end of the session we're going to destroy it using just a single command. But from this one that we did the last time, still there in the account collecting money. If we go to, I think it's Stockholm. If we go to Stockholm and we want to delete this particular resource now, it's going to be a really painful one because I have to do it one after the other. Any question? Good. There's no question. Because we don't have any question, what we're going to do is we're going to use this particular VPC to provision our instance, okay? And I think my plan is to do something similar to this. I hope we'll have time for it. Basically, we're going to spin up an EC2 instance. I think we're going to spin up one in the public and one in the private. Let's see. And then we're trying to establish an IPSec VPN between these AWS clouds and our on-prem server room or data center, if I can call it here, because here I have another server locally somewhere here that we're going to use for that test. I hope you guys will find this one interesting. Okay, let's jump into spin up the EC2 instance. Let's see, where do we start from? Okay, we're back to the console. All right, thank you for the cheering. Yay. Okay, let's go back to Ireland. And this time, what we're going to do is that we're going to spin up the EC2 instance, the first one in the private subnet 1. I think this one already has the routing table in place. That's fine. Okay, for us to spin an EC2 instance, we go to EC2. Okay, here, we come to here. You see right now there's no resource here. We are in this region. We're going to click on launch EC2 instance. Now we have to give it a name. PV server 01. Just a name. You can give it any name. Now you have the option to choose between the various operating system. Amazon, Ubuntu, Windows, all the operating system. And if you need more, you can come over here and run a search against both the community and AWS managed one. And you can see over here, we have, this is the marketplace where, for instance, other technology providers have AMI for their various services. Like OpenVPN is one instance. Palo Alto has its own firewall or virtual machine. You see here, Palo Alto has its own firewall over here. FortiGate is there. Cisco, everybody is here. That means if you need an instance that is beyond what AWS is providing, you have various technology providers that have EC2 instance that they have available for their various services. That comes at a cost, of course. That means you are being billed for, I think, how long you run it. Yes, I guess that's what it is. Okay. But for this exercise, we're just going to stick to the standard one, which is, we can say Ubuntu. Okay, Ubuntu is this one. I think we're going to go with this one. That is version 22. We select that one. Okay, that means we've selected our instance. That particular operating system, that means literally we are putting a drive in that particular, we put in a CD or a bootable drive into that particular instance, okay? Now we have to select the instance type. And like I said, the instance type will determine the pricing that you're going to pay for it. And I think AWS has a very extensive documentation where you can just Google AWS instance type and you see all of them where there are various pricing. And also there's a particular website that does a very good job in putting them all together over here where you can compare them and contrast them to see which one is going to be cheaper for you. And you can see the price per on demand, the price per reserve instance for a Linux instance, Spot instance. Usually don't have pricing because it's being built somehow by AWS. The Windows on demand is also here. That means this is another link that you can actually use. Maybe let me just see if I can put it somewhere here in the chat for anybody who needs to compare various instance type, and that will come with its own price. And for this, we simply going to use a T2. Okay, I'll use this one, T2 small, which is, I'll use T2 or I'll use T3. And the T3 also, I mean, T2, T3 is usually generational stuff, but I would say based on the requirement that you are looking for, you choose the instance type you want, okay? Here, we're gonna choose a 2 gig, 2 vCPU. That means You can see the family, T3, the CPU, the number of CPU that you have in it, memory, blah, blah, blah. And you see the pricing over here, on demand per hour. This is how much it's going to cost us if we let it run in. Okay. Then we have keeper. There's two ways. You can either create a new one or let it create for you. Here, we're going to create a new one. Because it's a Linux instance, let's say AWS training. Just put key. Okay. Now we just created this keeper. Oh, yeah. That also means that I have to download it. Let me see, where can I place this thing? Okay, let me just place it somewhere here to make life easy. That means when you create your keeper, you are compelled to actually download it, because it's not something that you can download again later. And the keeper, usually what it does is that it gives you the private key, and the public key is used, is assigned to the server so that you'll be able to establish your SSH connection. And if you are using a Windows machine, or you're spinning up a Windows EC2 instance, the keeper is used to decrypt the administrator password. Okay, for those who are familiar with Windows. Now we're going to go to security group. Okay, remember when we were doing the network session, I made mention of the fact that yes, there are two types of firewall. You have network firewall, which is actually NACO, and then you have how do you call it, instance level firewall, or network interface level firewall, which is private to the instance, called security group. Here we're going to create a security group. Let it create one, or use an existing one, but here we are new. We're going to create a new one, and we're going to allow SSH to connect SSH ports. That means we are opening that port for inbound traffic to the EC2 instance. And where do you want it from? You want it from everywhere. But then I think, okay, let's proceed like that. I'm not happy with the name. I think we're going to use it. Let's do the public one first, because the private one will get a bit complicated. But for now, let's do the pub one. Okay, I'm just renaming the server. Okay, security group, blah, 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 which means that if you set this security group from anywhere, anybody can SSH into that server. The other option is I can actually bind it to my own private IP address, which is my IP address, which is through name resolution, to find my IP address and to assign it to it. Yeah, I think let's choose this option. And I will suggest for anybody who is doing any project that you are doing in the cloud, if that server is going to be exposed onto the internet while you are doing your project, always make sure that your SSH or remote desktop connection is restricted to your own IP address. Okay, you can open the rest of the port like HTTPS and any other port that is required for the application to be, or for your server to be accessed through to provide the application. But then for your SSH connection and remote management, always bind it to your own IP address, just to avoid the trouble of somebody snooping around and then connect to your server. Even though you may say, yes, the, how do you call it, the person that have the keeper, but somebody can just DDoS your IP address or that particular port for you not to be able to SSH into it. Then we have the storage configuration. And the storage configuration here, we're going to keep it at 8 gig. And like I was saying earlier, there are various storage type. For instance, here we have GP3, GP2, IO1, IO2. I'll leave it up to you guys to go and figure out the details. But in summary, basically, they are all SSD, but some are faster than others. Okay. And for this, I'm just going to keep it to GP2. Then we have the advanced details also, which here is mostly for the Windows machine and how the other configuration need to behave. But for now, I'm going to leave it here. The only thing I haven't seen that we haven't done yet is the network side. Okay, here we are. We had a security group aspect. We have the storage. Now I think we have to edit this session so that we can configure the network part. Like I said, the UI is always changing. I don't remember the last time I came to the UI. I usually do everything from Terraform. Now here, we're going to choose our VPC, and this is the VPC that we created. Now the subnets, because we say we're gonna make it a public instance. I'm keeping it here because after choosing the VPC, we have all the subnet available. This one is a public subnet. We're gonna choose this one. Now we have the IP address. We can force it to actually automatically assign a public IP to us. There's also a discussion around the public IP address that we can look at later on, which is the difference between a public IP address and an elastic IP address. Do you have anybody here who knows the difference between a public IP address and an elastic IP address? Any idea what's the difference between a public IP address and an elastic IP address from AWS side perspective? Okay, yeah. Okay, yeah. Lawrence?
Can you?
Yeah, go ahead.
Can you?
Yeah.
I think elastic IP address, once the system or the server is turned off and on, the IP will be retained. That is for that particular server. But for the IP, the public IP address, once the system is shut down or is restarted, you lose it. It has to change. So the elastic IP is specifically for your server, but the public IP address changes as and when there's either a restart or a shutdown or something.
Okay, I think you are almost there. You got a 99% correct with a small correction, which is with a public IP address, if you reboot the instance at the operating system level or do a reboot from the console, the public IP address will still persist. But if you do a stop start, then the IP address will change. Does that make sense? And what is the difference between rebooting and stop starting an instance? Maybe that's another good question to ask, so that those who are getting accustomed to EC2 instance for the first time can get as much as information as they can. What's the difference between a reboot and a stop start? Okay, Lawrence, go ahead.
Yeah, I want to try. So I think maybe I might get it twisted, but I think the rebooting is okay, the stop start is like from the way stop start. I'm trying to use the logic like the normal stop start, meaning like you stopping it and restarting it. Not like as in like something like auto restart, like how
like code boot. You set up the instance.
Then you start it.
Exactly.
But this time the rebooting is like how will I even explain the rebooting? Rebooting is like yes, like
yeah, let me just help you over there. Reboots basically mean that at the operating system level, you are rebooting the server. Like you do sudo reboots, or you click on the Windows, I think, start button and look for restarts. Okay, that is the reboot. The stop start simply means you press the power button or you click shut down on the machine, where the machine goes off completely with all power disconnected, and then you start it again. That is the stop start. And the nice thing that happened during that process is that when you reboot a server, the server persists or remain on the host on which it was before the reboots. But if you press a stop start, the server may move, the server definitely will move from one server to the other, like the underlying hypervisor. It will move from the one physical server to another one. For instance, maybe you're running a particular workload for a while, and you have the sense that something is wrong under the underlying that you are not quite sure of, but you suspect that it's not your operating system level issue, but is underlying. What we usually do is that you stop the instance and you start it so that your server will start on another host altogether. Okay, that's basically that. Cool, that's it. And then I think I will leave. I think that's what I'm saying here. Yeah, we are looking at a VPC. We define the subnets. We ask it to assign a public IP address, and usually what it's going to do is that it's going to assign a public IP address to it that will change when you start the instance. Then we have the security group. We are creating a new one. Maybe this one we call it public SVSG, basically security group. I think we fill most of the information. Now we can just click on launch. All right, this is going to take some few minutes to completely boot, like start the instance. Another interface. Like I said, the UI is always changing. That means if you use the UI today, tomorrow you may come and find a different UI from AWS. Okay. Now this server is spinning up. Let's let it boot. In the meantime, I also wanted to see if we can spin the other one using Terraform, but I think there's a lot of changes I have to do here to accommodate that. Okay, let me see if we can do that quickly. If it's taking time, we'll drop it. Okay, here we're gonna spin up a server. I'm just gonna take the proxy part out of it, or should I keep it? Okay, I'll keep the name as it is for the purpose of testing. Okay. And for this one, definitely what do we have? We have which variable? I think let's look at it. All the variables are coming from here. And like I said, with Terraform is basically you define a bunch of variable and then put in the details that you need. For this one, I think we could skip this session. There's no user data, I guess, for this one. Who has any idea what the user data for? Basically, user data allow you to actually pass in script to your server during the boot process. That means, for instance, you want to deploy an application during startup, you can put in a user data, and then automatically, as the server is booting up for the first time, the user data get executed, and then the application get installed. Okay. Let's see this one. Security group. This is coming from an existing code. I just don't want to do a lot of work. Yeah. Okay. Let's see. We also have the images that we are going to use. Is it good enough? I don't know. Okay, let's go to EC2 instance. A couple of things. We have this value. This one remains. The AZ is which AZ did we use? We said proxy. We're gonna look at the AZ soon and make sure that the AZ also align with where the VPC is. Otherwise, we can do. Let's see. Let me see what we have over here. Okay, we are using this particular region, which is the AZ. Okay, I think it's aligned with what we're already using over here, which is EU West 1. This one is also EU West 1. That's fine. We got no trouble over there. Back over here, what do we have? The VPC subnet. Obviously, I think this is going to change because we are using a different module. And the module that we have here, how many people are familiar with Terraform in this group? Who has been playing with Terraform for a while? Anybody? Okay, all right, cool. What have you been using Terraform for?
So I use it mostly to provision an ECS.
Okay. Yeah.
ERS stuff.
Okay, cool. And this one we're using private. That means what I would do is that let's look at the naming convention of refactoring subnet, how do you call it? Terraform code can always be a pain. Okay, we're looking at the first one is a public one. This time we're going to use the private subnets one for that. That means we come over here. We change this one to private subnet. I hope that worked for us. And then, okay, the MI is remaining like that. Yeah, the access key, obviously the key name that we are currently using. If I come over here and I come to key pair, I think this is the one we created. That means we're going to pick up this name, because for every EC2 instance that you deploy, you need to assign a key pair to it. The only time you don't assign a key pair to it is when probably you have imported you have hard-coded your own key pair initially, your public key in the instance before creating an image from it. Okay, I think that may be too advanced, but basically what I'm saying is, for every new instance that you deploy, there must be an associated key pair, and that key pair allow you to log on to that, to connect to that particular server using your private key or the private key that you've downloaded, where the public key is actually stored in the server. The only time you may not need a key pair is that when that particular instance that you are spin up is coming from probably a node image in which you have your own public key already put in as SSH public key. Okay, that's okay. We're keeping the disk size. This time we're using a different storage type. And then what else? Then on the security group side, we're going to create a special security group that will be proxy SG ports, where we will have all these ports open for that. I think the only one, yeah, I think that's it. Any question? Okay, somebody's joining. Cool. I think that's it for now. While the Terraform is there, let's go and see our instance. Okay, this is the instance is currently saying is running. And we can see the configuration. These are the property of your instance. The detail, you have the public IP address, which means that this one will change. The private IP address is actually 19.1 because it's inheriting its private IP address from the subnet. What else do you have? The image that was used, that's not really relevant. Then on the security side, we have this security group that was created with this port open. And the port is open to this particular IP. And I believe if I go here and I say, what is my IP? Let's see, is it this one? No, not this one. Let's say, I guess this one is going to detect. Okay, you see, automatically this is the IP that is using. Second. Cool. All right. What am I? Okay, here we are back here. Okay, that's the server. Now, how do we connect to the server? Usually when I right click, I believe if I click on connect, there are 3 ways or 4 ways. Now there are even more ways of connecting. You have EC2 instance connection using the public IP address, which is then you have the session manager, then you have the SSH client. For instance, we just pull down the SSH client, the SSH key that we can use to connect to. There's also this option which is like the direct connect. Basically, it's like you connecting a monitor to that particular instance. Let me see what will happen if we click on it. If it will connect automatically or not, or it will access to do something. Okay, it's establishing a connection. I think this one usually doesn't work with T2 instances. Yeah, exactly. It's an error, blah, blah, blah. Okay, we can skip that for now. Okay, now we're going to use the SSH key. Let me try to pull up a terminal. CD. Home. Hold on. I think I'm connecting to the wrong. Let's see. Just give me a second. CD. Okay, let's touch. Okay, hold on. Okay, we can come back to this one probably. Let me try to see if we can use it from here. Here we are in this CD user. Okay, I think, let's see. AWS, I think this is the key. All right. But usually what will happen is that when you're trying to say connect, first of all, you need to adjust the permission onto that. And you can see the command is also there for you to just use, which is you change the owner to yourself. Okay, now if we do, you can see that, let me see, did he, okay, at least I should be able to read it. Cool. And I think now if you want to connect, you simply have to use this command to connect to it. Let's see if that one will work for us. Here we go. We're actually in that server. Okay. Can you guys hear me? Yeah.
Yeah.
Okay. That means we just provision the server, and because the server is public, we've been able to connect to it. Okay. And we don't have to do anything complicated. We are connected to it. And if you are using a Windows, if it's a Windows server, the similar procedure applies, but just that this time you're going to use your private key to actually decrypt the root password. Okay. But I don't think we need to do that today. Cool. That is for that particular server. Now, let's see if we do, let's see what we can get out of this one if we use if we're trying to provision a second server using Terraform, okay? We just fixed this one. I hope it's to the standard that we are looking at. There's no profile, user data not needed. Yeah. Okay, I guess can leave it this way. Now we're gonna go back to this particular directory, opening terminal. Okay. We're gonna use the same thing, which is Terraform init. Now log the vault. Let's see. It's now pulling 2 additional modules. Let me see if there's anything I've left out. Yeah, on the output side, I think I left the outputs. Basically, the output allow you to look at the configuration that you like, the property or some of the settings that you need to connect to the server later on. Local host. Is anything here that we need? Now I don't think I need anything from here. Yeah, okay. I think we can do that. Let me close this one because this is going to be an error. Basically, what I do over here is that automatically I'm going to create a port that will allow SSH and RDP over my own IP address, okay? It's not really relevant, but we can make use of that here. Okay, now let's run Terraform validate to see if there's any error. Oh yeah, we got a lot of errors. Yeah, starting from this one. Yeah, that's the security group aspects in which file, EC2 file. Yes, because we made some few changes, we need to adjust that somewhere here. Let's see, which one are we looking at? Line 39 is this one. Yes, because we changed the VPC. We're gonna come over here and replace this one. Okay, that gives us that one. I think there's another one over here too. And then the second one, I think is the same, that is 48. Yep, that's true. Let's now run validate again. Okay, no error. You guys can interrupt if you have any question, okay? And then we run Terraform plan. Let's see if sometimes maybe there's another error somewhere that we couldn't catch, but I don't think so. Here we are. We are basically creating 4 additional resources, which is the instance, the private IP, blah, blah, blah. Okay, now let's just do apply. Say yes. There we go. Let's see if we're gonna get an error. Let's just pray there's no. Oh yeah, there's an error somewhere here. Yes, EUS1. Okay, so this one is invalid. Subnets. Okay. Let's see where's that error coming from on the main file. Gravity zone. Let's see. And that is the trouble with refactoring old codes. You're going to be catching error here and there until you are done. Okay, AZ. Okay. We say we are using this. Let's see, what is it saying here? You guys can also read through the code and then see. Okay, it says it's not valid. Private error is not valid. It's invalid. I mean, it is in A. Okay, that means I've screwed up somewhere here. Okay, cool. Oh, yeah. I think what happened is that this is C and the instance is in what? Let's see. The instance is using AZ here, but then where did we get it wrong? Hold on. If we pay closer attention to the code. Okay, create instance in EU West 1C parameter valid. Subnet is okay. What is the line that we need to pay attention to? Let's see. Give me the line I'm looking for. Let's see. This one is going to main 21. This is going too far. Let me see. Control J. Availability, because this one is actually the module itself that Terraform will pull. That means what happened is that there's a mismatch between the subnet ID that we provided and the AZ. That means I'm gonna go back and look at the EC2 instance here. You see this subnet? This is where we made a mistake because the AZ we're providing is in a different region altogether. There's a mismatch. Now, what we're gonna do is that let me see, you're turning private. Then let me turn this one to 3. Let's see. So that it will align with it. Because if we go here, let's say this private 3 is where in this subnets, VPC and then variable, yes, is in C. Yes, I think that is where we made a mistake. Okay, all right, let's run, apply again and see. Now, sometimes some of the errors are not caught at the beginning. They are caught during the execution. And that is some of the painful parts of Terraform is some resources are deployed halfway and then the error is caught. I mean, I think in this particular example, we were matching a subnet that is in a different we were matching a subnet to the wrong AZ, whereby a subnet and the AZ must stay together for you to be able to provision the instance. Okay. All right. I think right now the instance is being provisioned. And definitely that instance is going to be provisioned in, let's see if we can refresh this guy and see. It's ongoing right now. It's being provisioned. Obviously, it's going to be provisioned in a private subnet in which definitely we will not be able to SSH into directly. Okay. Okay. Yes. Instance has been created. We have how many minutes? Let me see, moderator, how many more minutes we have right now? Because there's a last stage I want to go before we close this chapter, which is you connecting your private subnet, like your data center to the cloud using an IPSec VPN. Okay. I just want to catch that before we close, but it's also depends on how much time we have. Are you guys all okay? Should we proceed?
Yes, yes.
Okay, all right. Cool. That means the VPC, the EC2 instance has been created. Let's see. This is the detail. You can see instance type, the private IP. Obviously, it says public, but we know because it's in a private subnet, definitely this value shouldn't be here, but never mind, it's running. Now let's go and investigate what we have. This is the instance. Let's look at the subnet. You can see the subnet is showing private. Yeah, it has reserved an IP, but you see the IP is not assigned to it because it's a private subnet. And private instances in the private subnet are not reachable from the internet. That's the rule of thumb for that. The storage, that's it. Over here, we can see the volume is 10 gig, blah, 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 and all those things. Okay, now we just finished deploying an EC2 instance or two EC2 instances, one in the public and one in the private instance, private subnet. Let's see, is everything okay? Okay, right, another catch. Okay, the instance is showing in stop mode. Let's see, why is it stop? Oh, yes, it's a stop because in the Terraform code that we are refactoring, we did something sneaky over there because I said this is coming from a project that I did earlier. And in the project, when we come here, I put the instance in stop modes. It's basically a variable to be able to spin up an instance and not have the instance running because it's still a work in progress, okay? I think if we change it to running and I run Terraform apply again, it should be able to start the instance for us instead of start it manually. Let's see. Okay, it's changed from stop to starting to running. Then we can say yes. And let's see. This is just another catch because I do remember that I put the status in because I factored in a module that I've built for a particular project. And that's the price to pay for refactoring old code. You have to be catching bugs here and there. And I believe developers are used to that, right? So
yes, we are used to
you're used to that painful exercise of
yes.
debugging EC2, debugging code. Okay, now the server is running, it's initializing. One catch. When you're running EC2 instances on AWS or you're running a server in AWS, there's one particular value that you should always pay attention to. This guy, the status check. Okay. I think there's a documentation on that somewhere. Sometimes you have an instance that is running out of CPU and the machine hang, like we have it on-prem, where your machine is frozen. The same thing can happen in a cloud, where your machine will be frozen, or the machine will stop responding. Then you see failed fail status check. When you see that, that means the issue is coming from the operating system level. That means CPU or something like that. You just have to adjust those parameters and then start the instance. Okay. That means you must always have this check. In the past, it used to be 2, now it's 3 because AWS is always adding new check to it. Let me see where I can find a value for that check. I think if I go to monitoring, now this one. Okay. The monitoring aspect gives you an overview of the CPU networking utilization. You can see the CPU here. We started at 5% to eventually drop after the completion of the booting. The network in and out. It's just an overview. This is coming from CloudWatch for monitoring purpose. Okay. Okay, and then I think the other one that we did, this one, obviously, can see provision by Terraform, storage, blah, blah, blah. Okay, that's it. Oh, yeah, let's look at the security group. See here, this machine, using Terraform, I've created all these rules without having to do them manually. And the other catch is that you see this last line over here is coming from this security group that actually make a query to what is my IP address and automatically plug it in for me. Okay, and it's actually convenient when the instance is on a public subnet, because if it's in a public subnet, then automatically you can actually SSH into it, whereby you have the rest of the port that are open for your application. And like I said, this is coming from an existing, I think it's a monitoring tool that I was building using Grafana, and that's why you see all those ports in. Okay, cool. Now we just finished the other part, which is EC2 instance. For the bonus, I want to add an IPSec VPN to this particular demo, okay? So that we'll be able to basically have a server somewhere here that is residing somewhere on my network or in the server room somewhere to connect to a private instance on AWS. Or even if not connected, you should be able to ping it for the purpose of this exercise, okay? All right. Then what I would do is that, how do we deploy an IPSec VPN on AWS? Let's go to AWS and go to VPC. Okay. Do you have anybody on this call that has already implemented IPSec VPN with AWS before? Anybody? No. Okay. All right. Cool. For us to provision a VPN, or let's say IPSec VPN to IPSec tunnel between our on-prem infrastructure, which is your office, and AWS, you have to do a couple of things. First, we come to the VPN menu. We have customer gateway, private, how do you call it, virtual private gateway, and then IPSec tunnel. The first thing we're going to do is basically define the customer gateway. And by the customer gateway means that the IP address or the other end, which is your on-prem gateway. Okay. Now, for these projects, we are using PFSense. That's what I use for most of my firewalls. And for this particular one, we are using PFSense. And what we're going to do is to basically define the IPSec tunnel from here, from PFSense perspective, to connect to AWS. Okay. Now, we start by defining the customer gateway. Customer gateway here, let's say AWS, or let's say AWS training VPN gateway. Let's say, does that make sense? I don't know. Okay. Let's say DC VPN gateway. Okay. Now we need an IP address of the other side, which is on-prem. Okay. We've already catch the IP address before, which is this one. We're gonna plug it in here. And then we'll leave the rest at default. Okay. Maybe I'll give it a name also. I'll use the same name from here just to be able to identify that. And we're creating that. We just created an endpoint, which is the data center endpoint, your on-prem endpoint. The next step is to define an endpoint from the AWS side, because remember, when you're establishing a VPN tunnel, you're establishing a VPN tunnel between two subnets, or let's say two endpoints, your office router and probably the AWS data center router. Okay. Now here, we're going to come over here. And this time we're going to create a new one. Here, we're just going to give it the same name, but this time we call it AWS training, AWS VGW. Okay. We'll leave the rest at default. Okay. That should do the trick. Okay. We're waiting for this one to be provisioned. This one is done already, is already available. And this one is the AWS side. We are waiting for it. When it's done, the next thing we have to do is to attach it to our VPC. Okay? And this is our VPC. Attach. Okay. Now we just finished two things. We provisioned the two endpoints, attach it to the VPC. Now we're going to establish the tunnel. Now we are going to define the tunnel. Then you come to IPSec tunnel and you click on create. Here we're going to do training, and this one is DC to AWS. Okay. Now we're going to choose our private gateway, which is the one that we just provisioned from the AWS side. Check. Now we're going to select the customer gateway, which is telling the VPN configuration on the other side that, okay, this is the customer you're going to talk to, which is your home data center. Cool. Check. Now here we have the routing protocol. The catch is that for this, instead of using BGP, we're going to use static routes. Basically saying, what is this? Anybody asking the question? No. Here, we're basically going to define which IP address or which subnet are we going to connect to on the other side. I think if you go to information, that's what you're going to see. That is basically, we call it for the how do you call it, an IPSec term, we call it, encryption domain, okay? Simply just going to define the encryption domain on the other side. Now, for this one, let's see, what is our encryption domain? I'm going to come over here. Let's see. Now this one, we're talking about this one. Okay, this is our subnets from the other side. Basically, my server that we are going to use for this project, which is this one, or let's call it a client. Is on this subnet. You can see that is 10.250.250.0/0. Now, we come over here. I'm copying this one, and I think I'll adjust it later on. Then we come to the AWS side. Okay, let me close this one. Here, we're gonna put this /0. Yeah, I'm going to use this one. Basically, that is the encryption domain from my side. Okay. Now we're going to have a pre-shared key. For every VPN IPSec tunnel, there's always a pre-shared key. We're going to let AWS to define that for us. I'm just going to select this one, and I'll leave the rest to default. Okay. The reason being, what AWS does, like in traditional IPSec tunnel configuration, you must make sure that the two ends have identical configuration for the tunnel to establish both the phase 1 and the phase 2. That one goes to the network people that are on the call. But AWS allow you to be, AWS is kind of lenient in that department, where where the default VPN configuration on their side, IPSec VPN configuration on their side, include all those configurations. That means you don't have to do too much job, but just create the VPN, and then based on the configuration file from that's how you use your on-prem side to align with the AWS side. Okay. How many people have configured IPSec tunnel before? Like not AWS, but anywhere else? Anybody on the call that has worked on IPs? Okay. All right. Can you give us a small briefing on how it is most of the time? Maybe that will be helpful to the people on the call. Raphael, the mic is yours while we are waiting for this to complete. Yeah, Raf, are you there? I'm giving the mic to you. Okay, it's creating, and we just have to wait for this one to finish. And by default, when you create an IPSec tunnel on AWS, you are giving 2 redundant tunnels for high availability purpose. But most of our devices on-prem usually don't have don't have redundant tunnel unless you're using high-end Cisco devices or having FortiGates or Palo Alto. Most of the time, it's going to be one device that you're going to configure. And in this example, it's going to be just one device. Okay. While we are waiting for this one to finish, usually when it's done, we are given the right to pull the configuration. Okay, I think while it's still creating, we can pull the configuration. Now, this is another catch. You can see AWS IPSec tunnel support all these devices. That means you can have any of these devices from the other side, and it will be easy for you to establish a tunnel with your AWS. And for this particular purpose, because we are using pfSense, we're just going to click this one and then pull down the configuration. Includes sample optional, I guess so. And then we're going to use this one. Okay. Okay, let's see, control +++. Okay. This is what's after configuring the AWS side, this is the information that we have. And we're going to pick this information to now configure our side of the IPSec tunnel. Okay. Let's see if I can, how can I make this thing easier for everybody to watch? Because I just want this one to be part of the experience. Let's see, what do we have here? The first one doesn't really matter. Okay, tunnel, we have the phase 1 of the tunnel. That's it. Okay. Okay, this is the phase 1 information. And this is the phase 1 proposal. Okay, cool. All right, cool. I'm going to move this one to a different page, and I'll be fetching the information from here. For the purpose, we're going to use the same thing that we did before, because this is now a VPN pfSense training side, but I make sure that the AWS side is clear for everybody. What I'm going to do is that I'm just going to clone an existing configuration and do the same lazy thing that I've done before. Okay, this one, we're going to use it, AWS IPSec. Okay, let's see. If I put this one here, can we manage it like this? I guess so. We can manage it like this. And then I think this is the one we just did. Okay, cool. The exchange key is IK1. You can see over here. I'm just picking it from here. We are picking the internet protocol is our IP4. The one is there. Now, the remote gateway, which is the one from AWS side, I think is the IP that is giving us. We can cross-check that by looking at this. This is one of the IP. You see, that's the first tunnel, the same IP that we have over here. Okay, cool. That means we are on the right path. Now we're gonna go to the second one, which is the proposal side. We have mutual PSK done, main done. Then the destination, my identifier is gonna be my IP address. Okay, that means in this case I'm going to use an IP address, and then we come over here and copy this with the hope that this has not changed because I'm having a dynamic public IP address from Vodafone here. Okay, that is my IP address. Now the pre-share key, this is, let me see if we can find it here. I found a key somewhere earlier. Okay, the pre-share key redacted. If it's redacted, how do you want me to pick it up? Okay, let me see if I can find it somewhere here in the configuration or not. I don't want it to be redacted. That means, let's see. Okay, here it is. No, it's not that. Anybody seen the keeper here? No. I think we have to find a way of retrieving it somewhere else. Okay, I'll figure it out. Now, for now, let me see if I can go. If I go to the tunnel itself, can I retrieve it from there? I wonder why it's redacted from this. Okay, let's see. Where can I retrieve that key? This is here. This is the pre-share key is not showing. Action. Modify tunnel. Let's see, there's an option, not this one. All I need now is to be able to retrieve the key, but let me see if I'm trying to download it again. Would it allow me to show the pre-share key? Let me see. Okay, let me just see what I'm gonna get if I pull it again. Okay. Will you redact it again? Yeah, it's still redacting. Okay, let me see. Let's figure out how do we retrieve this key. Otherwise, how do we modify that configuration with a new key? Action, modify VPN, show my tunnel options. No. Not this one. Okay, can somebody do some few Googling to see if we can find how we can retrieve the credential, the key pair? How do you call it? The share key between the two tunnel. Nope, that's not here. Interesting. Let's see. Secret manager. Did you put it in a? Did you put it in a secret manager? I'm not sure. Let me see. Okay, that's okay. Let's see if there's anything in secret manager for us. Might be, okay. Let's put it here. Retrieve. Okay, I think it has put it. It has put the key. I think the the share key in Secret Manager. Now I'm going to pick it up from here. Then we go back to our initial configuration, which is this one. Okay, we're going to replace this one with what we have over here. And then what else? Then we proceed to the lower part. Are you guys following or you're bored? If you're bored, let me know.
I'll follow you, but I've lost more.
Okay, where are you lost? Tell me.
I've lost with the configuration stuff.
Okay, basically, IPSec tunnel is in two phases, right? You have phase 1 and phase 2. What we did from AWS side is basically the AWS configuration of phase 1 and phase 2. And I think most network people we should be conversant with that. Now, what we are doing now is that we are now coming back on-prem, and in this on-prem scenario, we are using pfSense for that configuration. People will use a different device, but based on the configuration, AWS will allow you to download whatever device you are using. You can put out the configuration and then use that configuration to set up what you are doing. Okay, that means that's what we are doing right now here. We are just setting up the tunnel, nothing really special. Probably because this is the first time you are doing IPSec, then maybe that's the reason why you are getting lost. Okay. Yes. Now we finished the proposal. Now we are going to the second one, which is the algorithm. You can see over here, it's saying that we should use AS128. That means I'll move from here. I'll go to AS. I'll make sure it's 128. And then we are using which SHA? We are using SHA-1, which you see over here for the hashing. And then we are using DH group as 2, which is, now you see you are following. Now we finished this one. The rest is the defaults, okay? We leave it like this, and we click on save. Now we are moving to the second stage. Like I said, there are 2 steps. The first step is what we just did over here. Now the second one is inside here, which is the establishment of the tunnel itself. The first one is the negotiation of the tunnel, and the second one is the connection. Now we'll come over here and let's see what they are telling us over here in their documentation. Let's see configuration. Okay, let's see. I think we are dealing with this one. Let me see if it's added at the top here too or not. Okay, yeah. Now we have the phase 2 over here because this is the phase 1. That's what we did. Now this is the phase 2. Here we just put it, this one P2. Okay, the tunnel mode. We are using tunnel. He said we should leave the disable uncheck, which is there. It's basically giving us all the instruction that we need. Now we move forward. Now is now telling us that we need to specify our network. And this is the network on my side, which is your data center side. Here we are using these subnets so that we just have to select the subnet from there. And the rest, nothing really there. And then we are moving to, okay, now we have the remote side, which is the AWS side of thing, okay? Let's see what's VPC. Let's see, the side up block for our VPC is, let me go to the variable, Control J. Yeah, this is the AWS side of things. We're just picking up the IP address, which is the remote network. And then we put 16. Okay, now we go to the encryption phase where we have, this is exactly what we are seeing over here. This is the protocol that is allowed there. Then we are using this particular encryption, which is 128. That means we can uncheck this one. It's not part of the business. Then we are looking at the SHA, which is SHA-1. Let me see. I think there's something that is hidden somewhere here that I'm not seeing. Okay, that's SHA-1. Okay, that's fine. And then we have the group, which is 2. That is also done. The rest is default. And I'm assuming that this should be able to work. And then we apply. If you apply, now I'm going to come and look at the IPSec and trying to see if I can force the tunnel to establish itself. No, it's failing. That means we've got something wrong. We have to go and check. Let's see. And IPSec is always painful. What did we get wrong? Did we get the password? Let me see, is there any log we'll see? Diagnosis. System log. IPSec. Nothing that much we have from here. I think this is the other one. The new one is not showing. Okay, let's go back here and go to IPSec. Yeah, I mean, we got configuration wrong somewhere. We're going to spend another 5 minutes to figure out those one. And then let's see. Okay, the first one is this one. Okay, we go back here. I hope we are dealing with the same documentation. 447, this was one. IPsec, this one is done, this is done. This is done, main is done. My IP address is this one. The share key is this one, okay. I'm not, let's say, secret manager, retrieve. Okay, we are dealing with this one. Which is exactly what we have here. That is sorted. Let's look at the phase 1. 128. SHA-1. Group 2. The rest is defaults, which is good. And then you're going to the second one. Second one is this one uncheck. It's tunnel mode. We are using these subnets, which is the one where our server is located. No, nothing. The remote one is this one, 19.6/16, which is also good. Then we have the encryption protocol, 128. This one is saying is .1. The group is 2. Okay. It seems not to be anything wrong on our side. This is strange for us. Let's come to VPC. Okay, this one is fine. This one is also fine. It's still showing down. Okay. Oh, okay. Let me see. Okay, this one is from AWS side. That is fine. Cool, cool, cool. It looks like we're trying to figure out why it's failing, but this may take some time for us to troubleshoot. Let's see this one. We don't need a route for now. We just need a tunnel to be up. Okay, this is our endpoint. Data center side, AWS side. And this one is also okay. Pretty sure key is there. Tunnel is there. What is missing here? Remote gateway, this one. I'm pretty sure it got to do with something with the keep. Yeah, I think we are now 2 hours in it. Hold on. Do we have this DP enable? Dead peer detection doesn't matter. Hold on. Did I forget something? Just give me a second. Let me see. No, that shouldn't matter. But our rule shouldn't matter here because IPSec tunnel should come from anywhere. Okay, cool. All right. I think what I would do is that I'll do some troubleshooting offline, and then we'll make that session available later on. Is that okay?
Yes, and that sounds good.
Yeah, I think that will make more sense. I think we'll do that. And probably even if you have to record this session, I'll make it available to you guys so that at least moving forward, you know that, okay, if you're doing your implementation on-prem, this is what it's going to look like for you to be able to establish your on-prem, because we don't have too much time. We've done already 2 hours. Okay? Cool. Any question from anybody's side for today?
Okay, so when we're setting up the VPN connections in the console part,
yeah,
we selected the VPC, all right. But I didn't see, unless maybe I missed it, a part where we selected the specific subnet that we want to connect to.
Okay, yeah. I think when we were defining the VPC, there's a session where I was talking about encryption domain, right? When we come here, let me see, where did we put the encryption domain? Yeah, you see here?
Yeah.
This is the route to our on-prem. This is the encryption domain from AWS to on-prem. That means if I do new now, you see here where we have the BGP for automatic route detection, you come to static.
Yeah.
That gives you the encryption domain.
Good.
Does that make sense?
Yes, and that means.
And here you have your, how do you call it? The AWS side, then you have the on-prem side. Then I think the rest you leave it its defaults because it's going to pick it up automatically.
Okay.
Does that make sense?
Yeah, and that makes sense.
Okay. Yes. That's it. Any other question for today?
I have one question too.
Okay.
When we're creating the EC2 instance, that's where like the public IP and then the elastic IP. That the public IP, when you do a stop and then a start, the IP address will change. Sometimes when you're connecting like specified domain and stuff, you need to connect this IP address stuff to it. So if that changes, it might worry.
That means this is what you do before you provision your instance. I mean, from Terraform perspective, I think that was easy because we took care of it automatically. But you can come to elastic IP address, and then you reserve one. Okay. You just click on allocate IP address. That means you're gonna ask AWS to give you an IP address. Okay, then this is the IP address that was given to you. Now we can now go to our EC2 instance over here. I think the one that we deploy in private. I think we go to action, I think networking, and then I think manage IP address. Let's see. See, this one is available. You can assign a new IP address. And let me see if we can pick it up from here. Either you do it from this angle or you come to the IP address itself that you've allocated, this one. I think this one is unassigned. You can click on it, and then we associate the IP address to an instance. You see? You can choose any of them, and this one is this one we were looking at. Automatically, it's going to assign it to this IP address and allocate it and reassociate it, blah, 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 and just click on OK. Now, this new IP address that you see over here becomes the IP address of the EC2 instance. Now you have a permanent public IP address. Does that make sense?
Yeah, that makes sense.
Yeah, that's how you go about that one. when you want to have, and I think that's the best thing to do, always allocate one. But also bear in mind that if you have an IP address that is allocated and is not in use, Amazon will be billing you for it. They are constantly changing their billing requirement. Therefore, that is one of those things that you have to pay attention to always. And because you are moving from on-prem to AWS, always evaluate your existing workloads. See the CPU utilization. Start small, and if you don't have a clear mind of what should be the instance type you have to use for that particular AWS instance, start small and gradually adjust it based on the need. Okay, because one of the major cause of high billing on AWS is over provisioning. And that's happened to every cloud provider. If you over provision, the cloud provider doesn't really care if you are using the resources that you have provisioned or not. At the end of the day, they'll make their money out of you.
Yeah.
Okay.
Okay.
Yes.
And then one last thing, when we talk about the scaling stuff, let's say I start off with 8 gig, then I scale it up to 32 gig for the storage. As I go, can I downscale it as well?
You can scale up instance type. That means, for instance, this instance is T3, right? I can go here. I think it has to do with instance change. There's a place where you change instance type. Let me see. Okay, we have to stop it. You stop the instance, and then you come to this session to change the instance type. Okay. Now, for the storage, that is not the case. When you scale up, when you increase the capacity, you cannot reduce it, because usually when you increase the capacity and probably after reboot, AWS will also expand the file system. Okay. As the faster, and you know, it's not possible to, I mean, you can use whatever tool you want, but it's always not advisable to try to scale down. That means with storage, if you scale up, you cannot change, you cannot reduce the size, because the file system is going to prevent you. And it's also another way for AWS to make sure that you don't corrupt your system. Okay. But for instance, you can just say, okay, this one, I'm stopping it. And then as soon as it stops, I come back, go to action instance setting, and then I'll change instance type and increase the memory. Because for you to increase the size, the memory size of a workload or the CPU size, you have to change instance. You cannot just say, oh, I just want the memory. I want to move from 8 gig to 16 gig without having, by maintaining the same instance. No, you have to go and adjust the instance type, because each instance type comes with its own CPU and memory capacity. Is that clear?
Yes, that's clear.
Cool. Let's see if this one will stop. It's still stopping. Yes, basically that's the summary for today. I think we go ahead and come over here, and then you see now it allows you to change instance type, and you can choose whatever you want to choose. If you want to, as high as you want based on your workload need, and you can see the property of that particular workloads, networking size, CPU, and storage, and also the pricing per hour. Are we good?
Yes.
Yeah, that's basically that for today. Today's session was mostly to actually focus on EC2. And I think we've done justice to that. I also wanted us to look at the IPSec side, but I think we ran into some small trouble. What will really happen with that is that it's literally going to come as a tutorial separately that we'll upload for that. Okay. Any question from anybody from your side? What are the plans that you have? No question. Okay, then I think from my side, I really appreciate that you guys took time off your busy schedule to attend this second session. And I hope with this particular session, at least you have a fair idea of what it looks like having to move workload to AWS. Obviously, there's more to this particular session, but I think it's something that we can take offline. But at the end of the day, it's really obvious that you can actually move any workload that you running on a prem to AWS if there's no real constraint around operating system. Even if there's a constraint around operating system, there's always a workaround that you can research around and then find the one that works best for you. But at the end of the day, like I said, we can move anything to the cloud, and the process is just about proper planning, and you're good to go. That's all from my side.
Okay, thank you, Christopher. Can you kindly share your social media handles where we can?
Sure. Yeah,
You
I will
can
do that.
share on the chat link where.
Okay, all right. My social media person that much? Not pretty sure, but let me see. I think you guys already have my LinkedIn handle. I think that's where you'll find me most of the time, if anything. Just give me a second. Let me see.
Okay. Guys, thank you very much for finding time out of your busy schedule to join this part two. Despite that today, the attendance was very, very low than the first day we started. But at least we've done something. So the video will be posted on our YouTube page. Those who follow us, you will get notification once it's posted. And once it's posted, I'll also share on the page for everybody to watch. So
Exactly. Okay, from the LinkedIn side, that's what you can find me here. I think that's all. Yeah.
okay, thank you very much, Christopher.
Yeah, thank you for your time and enjoy the rest of the week.
And you too.
Yeah.
So guys, thank you everybody for joining. Have a wonderful weekend. Thank you, Susu. Thank you.
Thank you.
Thank you, Steven. Thank you, Steven. Thank you. Who is TechnoSpark? Padmore, thank you for joining. See you some other time.